So welcome back, eBPF Summit. Thank you so much for coming here to be with us and to try to hack our way out of this container onto the network with us. I'm Tabitha Sable. I'm a Kubernetes maintainer. I work to help advance security strategy at Datadog, and I've been an avid CTF participant, team member, and organizer for some time. This challenge is a ton of fun. We have a to advance the plot here in the CTF, we need to be able to talk to a server out over a UDP connection, but unfortunately for us, that has been blocked by our enemies. And so we're hoping that using BPF, we can bypass this problem, get a code that we need in order to help and be able to bypass the blockade in the story here and go get our friendly bees. So we have 4 awesome hackers here today who are going to try to do this for us, and they will introduce themselves.
Hey, I'm Martinas, joining from Swiss village in Swiss Alps, and my favorite dish is pineapple pizza with ketchup.
Hi, I'm Cornelius. I'm from Zurich.
Hey everyone, I'm Louis. I'm joining you from New York.
Hi everyone, I'm Paul. I'm joining from my little sister's bedroom in Brittany, in France. My preferred dish is probably ice cream.
All right, so Paul, it looks like you have got the CTF challenge environment up and running here, and now you got to figure out what's the situation and what do you want to try to do with it. So let's go, and we're all here to help.
Great, let's get started. So basically, I started the Fedora VM. So if you follow the instructions, you can do this at home and you can reproduce everything we're going to do today. So I started the VM, then logged into it, started the Docker image, and then I have this small message. And so basically the goal here, as Tabitha said, is to connect to this IP and this port over UDP. To probably get some answer, I'm guessing. Okay, so let's try to do this. Maybe that's the first thing we can do. So in the instructions, we have a command ready to just connect to this. So I'm going to try that. Obviously, I'm not getting any answer if I try this. So what can I do next?
Maybe let's check with TCP dump what's happening.
With TCP dump, okay.
I'm pretty sure I've never had a network problem that I didn't try to apply TCP dump.
And that's true. Okay, so TCP dump, let's see if I have it at least. Yeah, okay. TCP dump, maybe.
Do we know the device?
Yeah, you might want to do.
Do you want to do the routing table maybe? Or
let's do everything.
That works.
Okay.
Yeah, let's do it.
Yep, catch all.
Okay, so UDP and the host I'm trying to reach. That looks all right. And let's try this again. And we don't have anything. Okay, so it looks like nothing is egressing on the device, I guess. But one thing that was catching my attention is in this message, there's something about IP tables, maybe. And as Tabitha said, it is actually an IP table rule that should be blocking this signal. So let's try to see this maybe. So this is the command from here.
Could you pass -C? This will print the counters for the rules.
Good idea. Okay, so we have the counters here. So what we can see is one rule. It is dropping everything that is UDP and destined to this IP, which was the IP we were trying to connect to. And 3 packets have been dropped already, so I guess that might be my 3 packets, maybe.
Seems likely.
You can try another one just to make sure.
Yeah, just to see it.
I'm personally a big fan of IP tables dash lowercase v lowercase n big letter L to kind of see this same thing, but I like the format of it.
You mean like this? Yeah.
Yeah, so you did hit it.
Okay. Yeah, so it incremented from 3 to 4. Okay, good.
So the firewall works.
Next.
That's a good sign.
Bad for us.
That is a good sign.
I guess the rules are saying that we are not allowed to modify that rule.
I think if you try to modify that rule, the results might be funny.
Yeah, the container might be killed, actually. Don't do that.
Oh,
yeah.
Okay, maybe let's not do that. Okay,
But try it at home. It's actually pretty funny.
Yeah.
But I think the message says something else, right, about the BPF folder. And since this is the BPF summit, it might be relevant to.
Yeah, it's not a net filter summit.
So it says I have left you a sketch in the blueprint folder. So the blueprint folder. Okay, that's pretty good. So this is the one, and I guess we have some stuff in here.
Oh, there's a README.
Huh. This is so nice. Okay.
As much as I love make, like, what is this make file actually doing?
Let's look. Okay, so it's building BPF, like some BPF program with Clang, I guess, here, compiling it. And then here we have some TC commands, which I'm guessing are maybe to load the BPF program in the kernel.
And it's acting on that WG0.
Oh, yeah. Yeah.
Which is a
So
ViderGuard device.
Mm-hmm.
Yeah, that one.
And there's a route to that?
Right. Yeah.
Cool. Cool.
So everything
Maybe
seems to
let's
be...
open the program.
Yeah.
Are you Emacs or VI guy?
Can't start the flame wars on a company challenge.
Ed is the canonical editor, and that's all I have to say about that.
It's gonna get dirty.
Okay, so we have some BPF program. If you've written one before, it looks familiar. So there's one first BPF program here for egress. And it looks like, yeah, there's a second one here for ingress. Or at least it's called ingress. I don't know if that's a trick. Oh, and the ingress one is complete according to the command. Like we don't need to change anything in there.
So from a high level view, like what we would like to do with this BPF program, I guess is one question.
Yeah, so I guess we need to bypass the IP table rule. So let me check the IP tables again.
So from the make file, I think we see that it's going to be attached to the TC ingress and egress. And this rule should be executed when? It should be before the TC egress, right?
Yeah.
So I guess we can do some modifications of the packet in that program.
Yeah, you mean like modify the packet so that it doesn't match the IP table rules?
Yeah.
Okay. So it's matching only on the IP and the protocol. I guess we're not going to modify the protocol. But
I don't
Good
think
luck
I
with
want
that.
to write a state machine in BPF.
Yeah.
That sounds hard.
So we can modify the destination IP, I guess. But yeah, I guess if the ingress part is already complete, yeah, so it looks like this is what it's doing here, right? So we have a BPF program on ingress. It's parsing the packet, so pulling everything from the packet, getting the pointers to the start of the packet, the end, checking if it's large enough. Okay, checking if it's UDP, checking if it's the IP address we expect for the source and destination. And then it's rewriting the source IP address. Oh yeah, the source IP address. Okay.
So it looks like it's doing a reverse DNAT, no?
Yeah, it looks kind of like a stateless DNAT.
Yeah.
Reverse DNAT. So I guess we need to do the
Yeah.
the other way around, so the DNAT in the egress one. Okay, so the idea is, if I understand this correctly, I'm not sure if that makes sense. We need to change the IP address, the destination IP address, so that it doesn't match the
IP table rules.
IP table rules.
Yep.
Okay.
And we also have a constraint on the DNAT on the ingress. So you'll want to use a particular IP address.
Oh yeah.
I mean, or disregard the comment that says you don't need to edit anything here.
Yeah.
I mean, this is a CTF. You disregard whatever you want.
Yeah, but what do we do if we do that? Then
Well,
we
then
have
you
to
have
rewrite
to-
everything.
Yeah, you got to take more into your own hands.
So I guess we can just copy paste the code, no, and modify some
that's
bits.
what I was, because I'm not going to do the like checksum replace and everything by hand. I never did that before, so okay.
I think there's an option in SKB store bytes that's supposed to fix the checksum for you, but I wonder if that, like, I wonder if that isn't working or something.
I don't know. I've never used that before. Okay, so let me try and maybe copy paste this. Okay.
And do we want to modify the source or the destination address in egress?
So if we just go by the what the ingress part looks like, I guess we want to modify the inverse of the ingress, but I'm not sure if that makes sense.
Yeah, I think it makes, like, we want to change the destination address,
Yeah.
then we'll bypass the rule.
Yeah, makes sense. Okay, so let me rename this. Does this one needs renaming?
Yeah, so this BPF program is going to run when the echo command sends the UDP packet to the interface, right?
Yeah.
Gotcha.
And it's going to run after the IP tables rule. Is that what we said before?
Yes.
Yes.
Yeah.
Because it by the time TC gets to see the packets, they've already been queued to an interface.
Yeah. Yeah, makes sense. Okay, so basically we need to send the packet with an IP address that is allowed. And once it went through IP tables, we can modify the destination IP address to the actual IP address we want, right?
Yeah, let's see how many copy paste errors you will make.
Yeah, this is tough with just like a stock Vim editor.
Yeah, people are watching you, Paul.
Thanks. You're supposed to help me. You're not supposed to.
Oh, come on, you got this. Check that.
I guess I need
Check
to change
that you have
one.
your constants the way you want them to be, though.
Yeah.
It's okay. Just think backwards and in hexadecimal. 100, 202, 1.
So what's the IP address we want to? Oh yeah, it's the 1.1, right? If I remember correctly, the instructions.
Yeah, because that's the real server from the instructions.
Okay. So what's the corresponding IP address? I have it here.
So I think it's in the big endian notation in network endian. So
Yeah, just the first byte.
yeah, I think you
Yeah.
just had to change the most significant.
Oh yeah, yeah, makes sense.
Yeah.
Yeah.
So
Yeah,
it's something
cool.
like this.
Did you
Yeah.
remember the CA64 part, or did you read it off of the screen? Okay, nice. I don't think I
it's-
could have remembered that either.
No, I can't remember that either.
You don't speak hex?
Only binary.
How does this look? Do we think the C compiler is going to like this?
Yeah, we can try to compile and see.
Yeah.
I mean,
Yeah,
I mean, that's what the compiler is for, right? It's the tool that you put your code in and it tells you your syntax error.
non-void function does not return.
Line 52.
That's only
guess-
a warning. Warnings don't
Yeah,
matter
yeah.
when you're in a CTF.
Ouch. Okay.
Actually, probably something bad would have happened if you didn't return there.
Okay, this looks good.
Mhm.
Yeah. What? Oh yeah. Hack.
Too much TCP.
Yeah.
Yeah.
Yeah. You got stuck.
Okay.
And I think you can type make run, or what was the target? Yeah. Make run. It will attach the.
Yeah.
Yeah, cool.
Okay. So we can maybe check if
Hey,
it's there. What?
Oh no.
No.
I
wait.
think
Oh, put a big X on your TCP dump so that we can see the hexadecimal contents of the packets.
Oh.
yeah.
Um,
If you want to see the attachment, you can do it with TC. It's like TC filter dev.
so TCP-X.
Capital.
Capital.
Oh, okay. I've never used that before. Okay.
I think you need to change the destination IP address, no?
Oh, right. Yeah. Okay. So what was the IP address we used? Like
Dot
Was
two.
3.
Yeah.
Okay.
Oh.
Oh, that's too easy.
Ah,
I didn't
cool.
even type anything.
Nice. Let's flip over. Let's look at the packet.
Very cool.
There it is. So look, by the
nice.
time you actually see it, we're really talking to 1.1 on the
Yep.
interface, but the kernel doesn't, like IP tables doesn't know we're doing that.
Yep.
Ha, so eBPF versus IP tables 1-0.
So like the thing that gets me about this is TC, you're classifying traffic for traffic control. Why is it that you can modify the contents of the packet in a BPF TC hook? And I think the answer is because it's eBPF. Like, it's programmable. How are they going to stop you? So like, I love this because you can do it, but it's like, oh no.
So I'm curious to continue to block this problem, right? You would just have a wider IP table rule.
Or not allow untrustworthy individuals such as ourselves to
Yeah.
run BPF programs.
Yes.
Yeah,
Yes.
probably. Yeah, I mean, you need to be privileged to like load the BPF program in this case. So yeah, if you're root on the machine anyway.
But it's pretty neat to see that we can actually modify the packet in there.
Yeah.
Thank you all so much, and congratulations for finishing this, like, even within 20 minutes. Like, that's pretty fabulous. We are now getting here to time. So as we get to the top of the minute, any last thoughts?
I think I really hate pineapple on pizza.
I'm going
I
to
mean,
finish my pizza.
Honestly, I like pineapple on pizza too. So yeah, thank you so much. We will now turn it back over to Duffy to introduce our next group of speakers. Thanks so much for playing. Thanks so much for tuning in. The new challenge is going to go live soon. You'll see it on Slack, and we'll see you tomorrow at about this time to live solve that one.